So for this video, we're actually going to be using the right triangle similarity theorem to find a missing side length. So this will be really similar to our previous unit on similarity, where we're setting up those proportions. We just now have basically 3 different triangles in here. And so there are many possibilities for how you go about setting up these proportions that will all give you the right answer. I'll just show you one way that you could look at it, but there are many ways that you can get to the right answer. So I know that all 3 of these triangles are all similar to each other, so I really just need to choose 2 of them to kind of separate out and set up that proportion. So I'm going to go ahead, just because it's easiest, I'm going to use the large triangle, and I'm going to go ahead and just redraw it underneath. So I can look at just that triangle. And I see it has side lengths 3, 4, 5. And then now from here, you can choose either the small triangle or the medium size. I'm going to go ahead and go with the medium sized. I have the right angle here, and so I need to look to see where my right angle is at, and I see my right angle is at H, so that means I need a vertex here. My smaller leg is HG, so that means G goes here, and then F. And then I'm going to fill in the sides I know HG is X, and GF is 4. And so now from here, I can go ahead and write a similarity statement. So I know that triangle GEF is similar to triangle HGF. And so now I can go ahead and set up my proportion. And so I'm wanting to find the length of HG, because that's where my X is at. And so I know that HG is going to go with GE, or you can just look at the picture. They're both in the same spot, both the same type of side. So my left fraction is going to be GE over HG is equal to, well, the only other side I have on this bottom triangle is GF, and that's going to go with EF. And you can also see that from the picture. They're both the hypotenuse. So that means that this is going to be equal to EF over GF. And remember, just from that previous unit, the top fraction needs to come from the same triangle. The bottom of the fraction also needs to come from the same triangle. So make sure you are doing that. You could flip these, but you just need to make sure you're staying consistent. So plugging in all my sides now, I have that GE is 3. HG is X, EF is 5, and GF is 4. And then I can cross multiply, so I have X times 5 is 5X, 3 times 4, I get 12. Divide both sides by 5, and I get that X is equal to 2.4. Okay, let's try another one. So here I have this triangle. I'm going to first start with just redrawing the larger one to kind of separate these out, and I can really see then what are my corresponding sides. And so this has side lengths 5, 12, and 13. This time we'll take my smaller triangle, so KLM. Again, you could stick with using that medium-sized one. You should still end up getting the same answer at the end. And so for LKM, I see that my right angle is at K. My shorter leg is with L, and then that leaves m. And then its sides are km is x, and lm is 5. And so here I see that triangle JLM is similar to triangle MLK. And so now I can go ahead and do my proportion. And so I see that x is on this bottom side, MK, and that's going to match up with my side, JM. So I have JM over MK is equal to, my only other side I have on my smaller triangle is my hypotenuse, so I'm going to go ahead and write that fraction here. So my hypotenuse on my big triangle is JL over ML. And now substituting in those values, JM has length 12, MK has length x, JL has length 13, and ML has length 5. And then now I can go ahead and cross multiply. So x times 13, I get 13x. It's equal to 12 times 5, which is 60. Divide both sides by 13. And you should get that x is equal to 60 divided by 13, which is approximately 4.62. This one we did have to round, but that's okay.